here is the Pear Deck link. If you're not in it, or if you just came, we are gonna get started.
Has the link.
Yeah, links in the chat. All right, so we are actually going to tie some of the things that we've been learning in math to the pandemic that we're all living in, unfortunately. And we're going to be trying to answer this question: why has it been so difficult to control the spread of COVID-19? Okay, so I want you guys to kind of think of that as we're going through today's lesson. But before we do, let's just kind of take a second to check in on a spectrum of great, which would be thumbs up, to awful, thumbs down. Where are we today? So let's see where we're at.
So far we have 7 responses. That's good. We're almost at 13, which we should have a couple more people in there, I think. Yep. So hopefully you guys are looking.
All right, so it looks like we're kind of all over the place. We got some people feeling really great, some people feeling awful. To those of you guys who are feeling awful, I feel you. Sending love, good vibes. Hopefully you'll have a better day tomorrow. All right. All right, so let's just do a quick warm up. I'm gonna take, 1 minute. I'm gonna put 1 minute on the timer, and I want you guys to just quickly write down or draw 2 things that you remember about linear and exponential functions from Tuesday's lesson. So if you guys remember Tuesday, we did Desmos, and we looked at Avi, who got paid a penny doubled each day at work. And then we had Bonita, I believe, who got $100 per day. And we looked at kind of how those functions changed and kind of what those 2 types of functions are. So let's take a minute. I started the timer. Remember, if you guys do the work now, you don't have to do the Pear Deck later for homework. So I see 5 out of 14. If you're not in the Pear Deck, make sure you are there or getting there. 2 things.
So I saw a couple of people. So please do click the link. If you can't see it, just let me know. Write it in the chat. Thank you, Fatma.
We got 20 seconds left. Take 10 more seconds to finish up whatever you're writing. 3, 2, 1. All right, that's the timer. All right, so let's see. Let's see what we got. Ooh, I love this. Oh my gosh, I actually love this. So we got a linear, actually, I think we're gonna probably stay on this one. We have a linear function, and this person made a straight line because linear functions on a graph are straight. And they also put a plus or a minus. When we were looking at tables the other day on Tuesday, if our outputs were either adding by a number or subtracting by the same number, that made it linear. On the flip side, exponential gives us this curve, and we found out that if we're looking at a table and we see either multiplication or division happening each time with the outputs, then that is actually going to be exponential. So awesome. That was great. Fabulous.
I think we have a question. Leo, I think, question.
Leo, do you have a question?
Or statement?
Yeah, I couldn't finish this problem because I just got in.
Okay, so Leo, you're gonna go back to the Pear Deck a little bit later and finish that up. Okay?
Okay.
Okay, cool. So I love this. We have like things about the graphs, Multiplying and dividing tells us exponential. Adding and subtracting tells us it's linear. All right, good stuff. And this was kind of, what we saw on Tuesday. I just wanted to point out, actually, most of you guys said most of these things. If we have a linear function, we have the format of y equals mx plus b. And if we have exponential function, we have this different format, which we're going to touch on today, but we're going to go more in depth next week. But it's y equals a times b to the power of x. A lot of you guys named this addition and subtraction for linear functions. The vocab word that we use is common difference. And then for the exponential function, when we have multiplication or division, we call that the common ratio. All right, and I think those vocab words were the only things that I didn't see in the warm-up. So just wanted to point that out. All right, nice job, guys. So as we get into today's lesson, I just wanted to take a second to acknowledge that some of us have, lost loved ones or really suffered. I think we've all suffered in some capacity during this pandemic, but I also know that this might be really difficult for certain people to discuss based on, your experience. So if talking about the pandemic is something that you just absolutely cannot do, I totally understand. Email me, and I can come up with an alternate assignment for you. Okay, so I just wanted to throw that out there. Yeah, all right. So what we are going to do is we're going to start with a video. The video is about 2.5 minutes long, and it kind of talks about the very beginning of COVID and how it began to spread in China. All right, so what we're going to do is we're going to watch this. I'm going to show it on my screen. I'm going to have to mute myself so you guys can hear the video, but I'll still be able to see the chat. And afterwards, we are going to answer a question based on this video. So make sure that you guys are watching. Let me get this video up and share this tab. Okay. Again, I'm going to mute myself, but I can still see the chat. So. No, come on.
Hundreds dead, thousands infected across multiple continents, millions quarantined with whole cities in lockdown. But how did the coronavirus spread so quickly? We're going to trace the virus day by day over the first month of the outbreak, following its path from patient zero in China to across the world, and what might happen next. As people everywhere celebrate the start of a new decade, the World Health Organization is told that a handful of people in the city of Wuhan in China had pneumonia, with no other clear causes or origin. But there's one common theme that connects the patients: Hunan Seafood Wholesale Market. Many of these first cases are linked to workers at the market selling live fish, birds, and other animals. As a precaution, the market is shut on January the 1st. Nearly a week later, on January the 7th, Chinese authorities say they've identified the cause of the pneumonia, a new virus in the wider coronavirus group, which includes the common cold and SARS. Now, this sparks serious concerns. 17 years ago, the SARS epidemic began in China and went on to kill 800 people. The new virus is temporarily named 2019 NCOV, what becomes popularly known as the coronavirus.
今天，湖北武汉市卫健委通报
2 days later, on January the 9th, the first death is confirmed. A 61-year-old man. He was a regular visitor to the market in Wuhan. By now, 41 people are known to be infected with the virus. At this stage, Wuhan's health commission says there's no evidence the virus could spread between humans. Yet by week 2, the new novel coronavirus isn't just affecting China. On January the 13th, Thailand reports its first case. Now, to understand how and why the infection spread, it's key to look at the timing of it. Reports of the first death in China came just before Chinese New Year, the country's biggest holiday and a time when millions are travelling all across the country and abroad. As planes left Wuhan airport, so too did the virus. On the 15th of January, Japan reports its first case. Then on the 20th of January, South Korea does too. On the same day that South Korea reports its first case, it's confirmed the coronavirus can pass from person to person. And official figures become clearer as the World Health Organization starts to publish daily reports. This is when the numbers erupt, with 282 cases reported from 4 countries. The next day, 314 cases are confirmed, including 16 healthcare workers. It then jumps to 581, with the majority still in China on January the 23rd. With the numbers rising,
Okay. Can you guys hear me?
Yes.
Okay, good.
Yes,
Okay. Sorry that I was just like keeping my fingers crossed the whole time that the video would load. The really important part of this video was that very end part when they start talking about how the numbers are rising so rapidly, right? They started with 1, and then, from one day to the next, the spread and the number of additional people infected kind of explodes. All right, so I want us to think about, what we've been doing in class and answer this question. So after watching the video, do you think the spread of the coronavirus would best be represented by a linear or an exponential function? So you guys are going to take the poll right on here. A, if you think it would be represented by a linear function, and B, if you think it would be represented by exponential. And if anyone wants to share their opinion. So I see Crystal has raised her hand. Crystal, why don't you go ahead? What do you think?
This question was kind of hard, but I think it was linear because it was increasing. So basically, it was going up. But for B2, I think it's B because it will go up and then it will go down and then it will go up and then it will curving.
Okay, so
it's kind of hard.
Okay, so
I'm in the middle.
Right. Okay, that's cool. And we're gonna actually figure it out by the end of this class. So that's good. I see in the chat Daniela said B, Leo said he thought A, Heaven's in the middle. Let me see my hands raised. Yuretsi, what do you think?
I think it's B because exponential, it's like curvy and it goes up and down. COVID-19, it wasn't like something that was ratio, something that was it had a form, it had an equivalent. The COVID-19 is rised up, it rised down. So I think it's an exponential function.
Okay, thank you. Let's go with Century and then Danielis, and then we'll move on. So Century, go ahead.
I agree with Yoretti, but I would like to add on. I think it's exponential because it is going up, but it's not going up at a direct pace like how it would be for A. It would go up 2 people, 2 people, 2 people, 2 people, but it's going up random single day, and sometimes it goes down, sometimes it's going like up and down, like it's different each day when once it's infecting new people. I think it's exponential for that reason.
Okay. Thank you. Danielle's, I know you wanted. So Danielle's hand was up, and then maybe we can go to the chat.
I agree with Century. That was pretty much what I was gonna say.
Okay.
Yeah.
And then Chalice, do you want to read what was in the chat?
Yes, so Lavette said, I think it just because it wasn't rising or going down with a pattern. It wasn't like the pattern, or I think what you were trying to say there is that you weren't observing the same pattern that you were looking at before when we were talking about linear functions. Correct me if I'm wrong.
Okay. Right. Okay. So we weren't adding by the same amount every day, maybe. Like we didn't have that common difference like we have been talking about with linear. Okay. So thank you guys. I'm just, while you guys were talking, and I was obviously listening, but also trying to figure out these breakout rooms. What we're going to do now is go into 2 rooms, one with me and one with Miss Chalice, and continue on with the rest of the lesson. So if you guys just give me 2 seconds. I think I'm getting better at this whole breakout room thing. It's very difficult though. I kind of hate it. Okay. All right, one more thing. Okay, so for the most part, we are split into breakout rooms. I'm going to open the rooms now. And so you should see, some of you are going to be staying in the main room with me, so you won't see anything. Others of you are going to get a join breakout room. So you're going to click join. Okay? All righty, I'm opening it up now. Okay. All right, I'm hoping that works. Let me just double check and then we'll move forward. It looks like we should be good. Okay. Oops, Skylar's in one by herself. Oop, give me one sec, guys. This is really hard to do. It's much harder than it looks. Okay. All right, so we're good. Let's keep going. So we all made a prediction, and basically what we're going to be doing for the rest of class is figuring out whether our prediction was correct or not. So, our guided question for today is, how does an exponential function model the current pandemic we are living through? Which I guess I kind of just gave you guys the answer. I didn't mean to do that. And then you're going to be able to connect the current pandemic to a function and see that function represented in multiple ways. All right, so well, that should have been, I did the breakout rooms a little bit early. Let's start modeling this spread using a table. All right, so I wanted to tell you guys the actual information. The World Health Organization says that the average person infected with COVID will go on and infect 2 other people. Now, for the purpose of this class, and just to make it a little bit more simpler with the math, we're going to say that actually each person only infects 1 other person. All right? So if 1 person has it, that person's going to infect 1 more person. All right? So I want us to take, let's take 2 minutes and see kind of where we get after those 2 minutes. Try to fill out this table. I'm going to be monitoring the chat. I'm also going to get into the Pear Deck myself as a student so that I can write on it with you guys. Are there any questions of what we're doing right now? I see hands. So I see Daniela's and Century, but I don't know if you guys are asking questions or if that was a mistake. Nope, that's okay. It's hard to tell. That's why I always just want to ask. All right. So we got 55 seconds left. $55 seconds. All right, good. So I see 9. I gotta see how many people are actually in my breakout room. So there's 14 people in the breakout room, and I see 9 people responding. So if you're here, make sure you're responding. At least trying. Remember, I only grade Pear Decks based on effort and completion. We got 5 seconds. Okay, let's see what Century put in the chat. Think of it like this. If one person gives it to another, now 2 people are infected. I love that. So let's see what we got. I'm going to show some responses. And actually right here, love it. So if one person has it, they're going to infect one other person. So now 2 people are infected, right? It's kind of like what Century said. Now, if 2 people have it, and I don't know if you guys can see my camera, but I'm using fingers. If 2 people have it and they each infect one other person, now we have 4. Okay? 4 people have it and they each infect one other person, we're up to 8. Okay? So can somebody tell me what is happening with these numbers? Are we adding? Are we subtracting? Are we multiplying, dividing? What's actually happening to the numbers?
We're multiplying by 2.
We're multiplying by 2, right? We're doubling. Okay? So let me actually, I want to slide down so I can write something. And it looks like, ooh, I'm loving this. Looks like we're all on the right track for the most part. Remember, so this I see where you were going here. You may have thought the rule was adding to. So we're going to talk about that actually in 1 second. Let me just find. All right, I just want to write so you guys can see. All right, so we said if there's one person infected, that person is going to infect one more person, and we have 2 people now infected. Then we go to 4. Then we go to 8, 16, right? This is what everyone was telling me. Okay, and Lewis told us, right, we're multiplying by 2. You're correct. I also wanted you guys to look at this, all right? From the very beginning to the next day, right, we had 1 extra person get infected, right? All right, from day 1 to day 2, well now, okay, we have 2 extra people, fine. Day 2 to day 3, we have 4 extra people. And I just want you guys to see what's happening here. Okay, so yes, we are multiplying by 2, we are doubling, but what's happening to the number of new cases every day? Can someone answer that question? What's happening to the number of new cases every day? Increasing. Somebody add on to what Century said. How is it increasing? By a little bit? By a lot? Rapidly, by a lot. Okay, so we're actually increasing by more and more each day. All right, so keep that in mind. As the days goes on, the number of new people becoming infected is jumping and getting more and more. Okay, nice work, guys. Let me move this out of the way. All right, let's graph. I am super nice and I didn't want to make you guys graph all the way up to 64. So I want you to take a second and graph these 5 points. And I'm actually going to do the same. So why don't we take a minute, graph as many points as you can in a minute, and we'll start to see what this is going to look like. Oops, what did I just do? All right. Just getting this ready for you guys because I want to show you something. We have 13 seconds left.
I can't really see the numbers on the graph. I like trying to guess like the points, but I can't really see the number.
I know it's tough. Hold on one second. Crystal, if you don't feel well, that's all right. Okay, just let me know if you have questions and we can touch base tomorrow. I hope you feel better. Yeah, and I know it is kind of hard. I just did it myself. It's a little bit hard to see the graph because it's so small on here, but let's see how we did. All right, love it. So this is kind of what the graph should look like, right? If I were to draw a line, let's see if anyone put a line on here. Okay, we're gonna come back. So I want to just point out one thing about the graphing, right? The first number is the x value. So I'm going to look, if I have 0, -1, I'm going to look 0, and then I'm going to go up to 1 on my y-axis. Hello there, whoever this was. Okay. Okay, we got a line here. So tell me, guys, we notice that this is now making what kind of shape?
Like a curvy shape.
Sorry, what was that?
A curvy shape.
Curve, right? We're making a curve. Okay. I want to show you guys one thing. So let me find mine really quick because this is really important here. All right, so this is my graph. I want us to look at the slope. Okay, so if we're looking at the slope at the beginning of this curve, I go up 1 and over 1, right? So I have a slope of 1. What about as we move through the curve? What's happening to the slope? I guess I should say, is it staying the same or is it changing? What do we think? So if I look here, right, this is a slope of 1, right? Here, if I'm going from this point here all the way up to here, I actually have to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1. So that's a slope of 8 over 1 versus a slope of 1. All right, so what's actually happening? The slope is getting steeper, less steep. What's happening? Let me put it in the chat. Is the slope getting steeper or less steep? Do we know what steep means?
Doesn't it mean like down, but straight, but like down?
Kind of. So if
Like something like a hill.
go
Like
ahead.
a hill.
A hill, right? Good. That's good, guys. Like when we think of the steepness of a hill, if it's more steep, it's almost like more vertical, right? It would hurt more if I fell down that hill. If it's less steep, it's more horizontal, right? So actually, thanks, Lewis. I see in the chat, this is getting more steep, right? And the takeaway from this is the slope is not staying the same, all right? It's starting out less steep. It's getting more and more steep as the days go on, all right? Or as the number of infected people gets more each day. Okay. I just wanted to show you that. We're going to look at that a little bit more on Tuesday next week, but that's kind of what's making this curve. And from the looks of it, you guys rocked the graph. So way to go. All right. Last but not least, and then we're going to answer some discussion questions, which I hope you guys enjoy. This is the format of an exponential function. So we have the y equals a times b to the x power. All right, so this, I just wanted you guys to see the different parts. We have the initial value stands for, or a stands for the y-intercept in the initial value. B stands for the common ratio. And then x is still the input and y is still the output. All right, so if you guys see here, right, we began with 1 person infected. So that is why a equals 1. The infection rate, right, and this is kind of what Lewis had said, was we multiply by 2, or the number of people infected doubles each day. So our common ratio is 2. X is the input, or the number of days, and then Y is the output, or the total number of people infected. Okay? Are there any questions of where I got these numbers so far? Okay, like I said, we're gonna practice writing these next week, but I just wanted to show you kind of how it relates to this story. Okay. This is for if you're doing this by yourself. There's a video kind of what I just explained, but we're not gonna watch that right now. All right, so now we really gotta think a little bit deeper. The first question I want us to answer is, what do you think would have been different if the pandemic had followed a linear pattern instead of an exponential pattern? Okay, so I want you to think about kind of what we've just been talking about. I'm gonna put 30 seconds on the clock and then maybe we can start discussing. So what do you think would have been different if the pandemic had followed a linear pattern instead of an exponential pattern? So let's take 20 seconds. I think this is a very important question. So make sure your mind's turning, your brain's working hard. What could have been different? What would have been different? Take another 5 seconds. 2, 1. All right. I'm hoping people would like to share. What do you guys think? What could have been different if it was a linear versus
Can I say?
Yes, Giannis, please.
I put that if it would have followed a linear pattern, it would have spread less quickly than an exponential pattern. Because it would have went +2 instead of ×2.
Love it. You're completely correct, Giannis. If we had gone +2 each time, right, the total amount of people infected would have been less for longer. Love it. Century, I see your hand.
Okay, I would like to agree, but I would like to also add on. I said that it would have been easier to control because I think because you could see the pattern, you could try to stop it if it's adding on in a steady rate. But because of the exponential pattern, which is uncontrolled and all over, it's harder to stop and harder to do so.
Love it. I really like, you guys, Giannis and Century kind of both touched on this idea of a steady rate, right? If we've been adding by 2 each time and it was steady, it wouldn't have basically exploded like it did. It wouldn't have spread as quickly. Amazing. Let's just see if there's any other responses that we want to highlight. Easier to control. It would have grown at a steady rate, spread less quickly, affected fewer people. You guys are amazing. They would have still increased. I love this. The number of cases still would have increased, but much slower. Amazing. All right, nice job, guys. Okay, so let's think about this now. When we social distance, quarantine, and try to flatten the curve, what specific part of the exponential function are we trying to change? And how does that keep us safer? So I'm going to put in the chat. Remember, we have the input, which was the number of days. We had the output, which was the total number of people infected. We had the y-intercept / initial value, which was the first person who was infected. And last but not least, we had the common ratio, right? Which was at the number of people infected doubled each time. Doubled infected people. All right. So take another 10 seconds. What specific part, and there could be more, so I just want to hear your guys' ideas. What specific part of the exponential function are we trying to change when we social distance or quarantine? Heaven, take it away.
I said the specific part that we're changing is the number of human interactions, because the less people who interact with each other, the less people get infected by COVID.
Agreed. Now, somebody add on to that. When we're talking about the number of interactions and then the spreading, what part of that exponential function are we talking about? I think Yuretsi had her hand up. And then Kai, I'm going to come to you in a second.
Well, we're trying to flatten the cases of COVID-19.
Mm-hmm.
So, like in that equation, right?
Yeah. So what part do you think that would be of the equation? We have the input, output, initial value, or the common ratio. Which one are we trying to change?
The output.
Definitely the output, and that was one thing I saw Kai put that in there. What else? There's one more thing that we actually are trying to change, which would cause less people to get infected so quickly.
Yeah, the common ratio.
Yes. Love it. I see Lavette, Hawa, the common ratio,
Yeah.
right? So if we can say, instead of one person infecting one more person, if we could get the numbers to say maybe, and this like realistically doesn't make sense, but if we could lessen that doubling part, so maybe one person only infects a half a person, right? Which mathematically or in real life that doesn't make sense, but if we weren't doubling each time, right, we can kind of flatten that curve, right? The numbers are not going to change as rapidly. Awesome. Good job, guys. So I agree with you. We would have tried to change the output, so the total number of people infected, but this social distancing actually is going to decrease the common ratio, which is going to cause the infection to spread slower. Nice. All right. One more. So how does this exponential model help us with understanding this pandemic? How does it fail us? So I want you guys, I know this is kind of an abstract question. Think about, like, why do we use math? Why would we try to use math to explain what's happening with the pandemic? And then maybe, how can math not help us here? So Century, I see your hand. I'm going to give everybody like 10 more seconds. All right, Century, go ahead.
Okay, I said that it helps us to see how the cases are spreading easily and how it's spreading in a way that we can't control. And I said this fails us because when we're using math, right?
Mm-hmm.
But with the math, it is explaining to us how it cannot be controlled, of how it's spreading too rapidly to contain. And like when using math, it's showing how the cases are like doubling or tripling or what, like, because we didn't use the exact measures, but it's showing that the cases are going really like quickly.
Mhm.
So it's like it's telling us that we're not going to be able to contain this like without a cure or whatever.
Okay, right. So thanks, Century. It's giving us information about like, okay, what's going to happen if we don't do something, right? If we don't socially distance, if we don't quarantine. Does anybody have anything else that they wanted to share? Let's see what we have here. They can study the rate of cases. Okay, so the virus might be spreading too fast for the model to catch up. I also want to just, okay. I don't know who put this, but this is what I was looking for. Amazing. It fails us by not showing 100% accurate results. All right, meaning that, for example, the next day, there might be more cases than what it should be according to the math. Amazing. So I just wanted to point out, mathematical models are helpful in that they let us predict certain things, right? But predictions are not always 100% accurate. So while we think, okay, one person is going to infect one more person, well, maybe that person actually infected two more people, right? So real life sometimes veers away from the perfection of the mathematical model. Yeah, or the whole family, right? If we're, together in a family, we might actually be infecting more than one other person. So that's where the model kind of can fail us in that way. Awesome. I really, really appreciate everyone's responses. And actually, it looks like Ms. Chalice is back. Hello, everyone. Welcome back. Stay so we can get your attendance. And also, I just want to see how everybody felt about this lesson. Did you guys like it? Did you not like it? I don't know if anyone
Also,
wants to share.
I let them know that if they didn't complete the peer deck as we were going, that they're still responsible for doing so on the post. So you're still responsible for that work, guys, okay?
Awesome. All right. So it looks like some people are right in the middle, and then others liked it. And I know we don't have a full set of responses because those other students were in the room with Miss Chalice, but hopefully this was interesting. It ties into something that we're all living through. Does anyone want to make any final comments before we talk about the homework? I think it was really good discussion. We heard from a lot of different people, so thank you. Stay safe, yes. Still wear your mask, right? We still want to control that common ratio. Awesome. All right, guys, so we have 1 minute left. I wanted to just give you guys one extra chance to complete the IXL. I think now you have a little bit more information about the difference between linear and exponential tables. So I wanted to give you guys that opportunity to continue that assignment if you want to get a higher score. Here's the rubric for how I'm grading IXL. And then last but not least, you guys do have a mini quiz tomorrow. So it's 5 questions. It is about the difference between linear and exponential functions. Think about the common difference. So if we have adding and subtracting, that's going to be linear. If we have multiplying or dividing, that's going to be exponential. It shows you a picture of a graph. You have to look at one table and determine which one is which. And that's about it. So it's only 5 questions. You can use your notes, but that will be happening tomorrow. So use tonight to make sure that you are, feeling confident with that. Okay? All right. I'm going to stop presenting. Thank you guys for your participation today. Everyone did awesome. And that's it.
Bye, guys. Make sure
Bye,
you
guys.
complete if you haven't done so already, please.
Bye, Roddy.
Bye. Bye, Yuretsi. Have a good day. Thanks to everybody who participated. You guys rock. All right. Let me stop. Ooh. Let me stop this recording.
I have a question.